Okay.
Hello.
Hi, Hussein. Why did you turn off your camera, Hussein? Huh?
Mm, when I joined, my camera turned on. I don't know why, but I don't want to turn on my camera.
Okay. It's okay. What can I do? Maybe after 2 or 3 months, you get used to it. After that, you start turning on your camera. Uh, Guys, good to see you again. I hope you all had a great weekend. And after all, Saturday, Sunday is a kind of, how to say, time to have some rest, right? For some people, but for some people, even Saturday and Sunday usually is busy. So now, if you have no any questions, I mean, if you have any question, we can have some discussion. Otherwise, we will continue. So as you know, we were solving these questions from Sasmo 2. Now we have been practicing, I think, since the beginning of February, right? Or the second week of February, I don't know. But maybe if you also practice yourself and come with some questions, maybe it would go much faster. But you're also so busy with your school stuff, school homework. We are going a bit slowly, but it's fine, I think. But at least, sometimes you need to have a look and try to solve the questions. Can you solve it or not? Do you remember the idea or not? Just to consolidate your knowledge. At that time, you can make some improvements. Okay. So we will continue then. All right. Is everything all right?
Yes.
Okay. Uh, so where did we stop here? I think here. Okay. Did we solve this
Hello.
question? Hi, Javid.
The answer is 10.
Did we solve it?
We didn't do with rhombus, but we did with any quadrilateral, but anyway, it is that.
Okay, good. So that is 10, right? Because at the first time we couldn't see that, because when you draw a circle and the rhombus, you can draw something like this, right? Okay, doesn't look nice. So anyway, I don't know how to draw this beautifully. So here, actually, this part, I need this part that's really important. What is it? Just a
Did you
minute.
canvas?
Just a minute.
Because we discussed it.
Huh?
Can we skip because we discussed it?
This question?
Yes.
Okay, good. Okay. So, and also this one, I think we discussed, right?
No.
Anyway, let's just solve a few, 2, 3 questions for warm up. After that, I will let you do those questions and have some discussion. And in this way, we will move forward. In this kind of question, what's the main idea? Find the smallest whole number, n for which 504 n plus, is a multiple of 168. Just we need to find the common multiples, right? Here, 5 for n. That means that I need to, when I divide this, actually it's a different version. When I divide 540n by 168, the result should be a whole number. So we need to find the minimum value of n so that also this fraction is a whole number. To do this one, how do we simplify this? We need to find the prime factorization of these numbers, 540 and 168. Both numbers are divisible by 2. For example, 270n, and here we have 84. And again, both numbers are again still divisible by 2, 135n, and here we have, what is it, 42. And are they divisible by 6, 3? It is 4, 9. Yes,
Okay.
they are divisible by 3. By 3, it is 4, 5. And by 3, it is 14. right? So now 45 and 14, they don't have any common factor. That means that they are relatively prime numbers. And only actually that will be the whole number when n is, what is it, divisible by 14. Since we are looking for the minimum value, so n must be 14, right? So when n equals 14, at that time 540 and it will be a multiple of 168. Another question, in triangle ABC, AB equals 10, BC equals 6, and AC equals 8. Find the value of sine of A and sine of B. Okay. Now, I mean, what do you think about this triangle? Is it a special triangle or not?
No.
I think yes. Why? Because here, as you see here, 10 squared, 100. 6 squared, it is 36. 8 squared, it is 64. And 36 plus 64, that's equal to 100, right? And Pythagorean theorem says that if the square or the sum of the squares of two numbers is the square of the third number, that means that those numbers must be the size of a right angled triangle, which means that this should be 6, this should be 8, and this should be 10. Okay, so what is 10? It is AB. So this one is A and this one is B. And C is this side, right? It is a right angled triangle. Why? Because of this relationship. It's a theorem. If A squared plus B squared equals C squared, that means that A, B, C are the size of a right angled triangle. Or if it's a right angled triangle, then A squared plus B squared is equal to C squared. Anyway, so now we have found out that that is a right angled triangle. And find the value of sine of A over sine of B. Okay, what is sine of A from here? By definition, sine of A is opposite side over hypotenuse. That is 8 over 10, right? And how about sine of B? Opposite side over hypotenuse. Sine of B is 6 over 10. So now the ratio sine of A over sine of B, that's equal to 8 over 10 over 6 over 10, which is equal to 4 over 3, right? What is 4 over 3? 4 over what? 4 over 3 or 3 over 4? Sine of A. ABC, BC equals, okay, this notation is wrong, right? This should be 8, AC is 8, and BC is 6. So at the time, sine of A is 6 over 10. Sine of B is 8 over 10. So 6 over 10, 8 over 10. The answer is 3 over 4. Okay, Hussein, I think it's quite easy question. Here, 0.75 is 3 over 4. Okay. Hussein, are you here?
Yes.
Can you read the question and let's solve this together?
All right. There are 15 rows of seats in a hall, each row having 20 seats. If there are 275 people seated in the hall, at least how many rows have an equal number of people each?
If there are 275 pupils seated in the hall, at least how many rows have an equal number of people each? What does it mean? At least how many
Is
rows
minimum.
have an equal number of people each? What do you say?
Teacher is meaning here we should find the minimum number.
Yes. Mm. It says there are 15 rows of seats in a hall, and if there are 275 people seated in the hall, at least how many rows have an equal number of people each? Okay. So if all are full, right, at the time it can take 300 people. So 15 rows. So at least how many? 19, 18. 13, right? Okay, 275 people seated in the hall. At least how many rows have an equal number of people each? At least. So 13, right? If each one is full, at the time here we have 260 people. And we have 15 more people. Maybe they are in row 14 or row 15. So at least 13 rows have equal number of people. Does it make sense, Arat?
I'm finding a smaller number in about 1 minute. Teacher, I found 8.
8?
Yes.
How is that possible?
First, see that we have, once again, we have 8 seats with 20. Then we have, 1 second. Then we have 19. Sorry, then we have 216 as well. And then we have 18, 17, 16, 15, and 14. Then we have 19 till 14. First, these are only 1, so the only left is these 2. So we have 10.
Okay, it says actually here to find at least how many rows have an equal number of people. Actually, we need to fill each column, right? Because here we have something like this, right? Here we have a kind of rectangle, right? And rows, it is 15 and seats 20, right? So now it says at least how many rows, right? To do this one, at least how many rows? So you're saying 20, 20, 28. 820, 160. Then
Teacher, I
here we
didn't
have
calculate.
32. And what is it? It is 10 rows, is it?
Yes.
And what is 19?
And 19 till 14 is mean 19 plus 18 plus 17 plus 15, 14.
What do you mean?
In the last one, in the first one, 8 times 20. It's mean 8 rows are 20. 2
Uh-huh.
rows are 16. The other one is every row is like this. The first one is 19. The second one is 18. The third one 17. Fourth one 15. And the last one 14. So it's mean 19 plus 18 plus till it go till plus 14.
Hmm. So at least 8 rows have equal number of people.
No, 10,
10? Why 10?
because there are two 16s.
Now, I mean, do you understand what we're talking about?
Yeah.
Yeah, sometimes, last time also we saw one birthday problem, if you remember. In the whole, there were 366, 67 students. What is the probability that two students' birthday fall onto the same date, right? Sometimes very easy questions, but if idea doesn't come, we cannot do this. Now, somehow I get stuck here. So all right, let's actually start from the beginning. Okay, so we have 15 rows and 20 seats in
Can
each
I
row,
draw?
altogether 300. If there are 270 people seated in the hall, at least the minimum, right? How many rows have an equal number of people each? At
Can I
least.
say my way?
Yes. Now say from the
Once.
beginning. What is the idea and logic and the methods you are using?
Firstly, I did like this: 19 plus 18 plus 17 plus dot 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 plus 1, which I got. It was not 275. So I started to add from the right side to make them 20. Then I got like something like this. Wait, 1 second. Then I got 20 plus 19 plus. Sorry, in here it has to be till 6. Yeah. Sorry, 1 second.
You
Like
mean
I
the
added,
first row, 20 people, second row, 19, third row is 1, 2, 3, 4, 5, 6, is it?
is it go
Okay,
till 6 because there are 15 rows. It mean till 20 plus it go just plus plus till 6. You shouldn't consider 1 and 2.
okay.
It mean here has to be 6 and 7. Then the number was something with 180 something. Then I added like to make the from the left side from here, make them 20. This means it became like 20 plus 7 plus 8 and so on. I added 20, 20, 20 till I got 8 20s plus that thing which it was 273. Then I added 2 to 14 to become 16. So I have 275.
So you are saying that in 10 rows, they are equal number of people,
In 8
minimum.
of them, then again another 2.
So what is the number of people in that row?
Um, 20, 20, 20, 20, 20, 20, 20, 20, 16 and 16.
What do you mean? I don't understand. Each row must have equal number of here. Why are you saying that 8 row, they
I
have 20 and 2 rows
sorry,
16? Why?
it is 9 20s. I replaced 9 20s. First, I show you. Wait one second. The first law is this 20, 20. So until there is 9 20s. Then we have 19, 17, 16, 15, and so on.
Okay.
And we don't have 18 because in 18 I added 2. So it will become 20. Because if you do like that, it would be 273. To make it 20, I added 2.
Okay. Narmin, Hussein, Javid, did anybody understand?
Yes.
What did you understand, Hussein? I didn't understand anything.
I didn't understand myself as well. How did you understand?
Narmin, did you understand?
No.
Okay, I am stuck. Anyway, Arad, good. So, okay, can we get back to this question a little bit late? Because sometimes when I'm stuck, idea doesn't come. I don't know. Now I cannot think anything. So we will get back to this a little bit later. I'm just waiting for my idea to come. All right. So Arad, you are speaking. I think you are right, but now somehow my brain stops. Maybe I'm a bit tired, or I don't know. But we will get back to that question soon. Okay. So let's just give me some time. Okay. Arad, read the next question. Let's see what we have here.
Tom drives 400 kilometers during a trip. He rotates the
1,000.
tires, 4 tires on the car and one spare tire, so that each tire has been used for the same distance at the end of the trip. How many kilometers are covered by each? Oh,
Did you ever see this question before?
no, but I got the idea.
Yeah. Also, I think, I don't know, maybe many, many years ago, I think I remember this question, this kind of question. What is it? Tom drives 4,000 kilometers during a trip. He rotates the tires, 4 tires on the car and one spare tire, so that each tire has been used for the same distance at the end of the trip. How many kilometers are covered by each tire?
Can you give 2 minutes?
Okay, let me give 3 minutes. Okay, let me also try on the paper. Let's see who gets the right answer. Time starts now. You're reading? Huh?
I'm
Good boy.
watching that but no sound that all I
Okay.
need to see it.
All right.
Is the answer 3,200?
3,200?
Yes.
But I got 3,000. I don't know why. How about others? Narmin, Javid, Hussein, did you get anything? Because here in a car, we have 4 tires, right?
Which I
Here we have
again
the
did
first
it is
one. Huh?
3,200.
How much?
I did it again. It is still 3,200.
Okay. Okay, let's see. Maybe you're right. How many times do we change?
And it is 1, 2, 3, 4, 4 times.
4 times. So that means that here we start, right, with 4, and at 1,000 I change this, at 2,000 I change it, and 3,000 I change this,
No, teacher.
and
I mean, at the end, if you count the end as well, it is 5. Because the end, you don't change anything. It is
yes,
finished.
1. First, okay, I tell 1,000, I change number 1, and travel another, I change 2, another 1, I change 3, right, another travel, and 4. That's it.
Teacher, but I did another way.
How?
And firstly, like if we imagine like this, we have the tire 1, 2, 3, and 4. In the first change, we change the first one. So it become 5, 2, 3, 4. Then again, this time we change the second one. So it become 5, 1, 3, 4. And 5, 1, 2, 4. And the last one, 5, 1, 2, 3. And in here, the first one is used 4 times. And the fifth one is used 4 times. The second one is used 4 times as well. And here and here. The third one also. And in the last one. And the fourth one 4 times as well.
So each
If
tire use how many times? 4 times.
yes. So it means the distance here is 1, 2, 3, 4, and 5. 400 divided by 5. It was how much?
800.
800. Then because each of them has gone 4 times, it means each of them was like changed. They weren't in one of the cases. So 800 times 4, 3,200.
Good. Yeah, that's right. You are right, Arats. You're saying that first, actually, we are using 1, 2, 3, 4, and we are using maybe 5, 2, 3, 4, and 5, 1, 3, 4, and
No, in
5.
here, teacher,
Huh?
in here we shouldn't change number 2. And then we change. Oh yes, we change.
Yeah, 1, 2, right? And 1, 4, 3, 4. Now after that, we don't change 1, 5, 1, 5, 1,
1,
2,
1,
4,
2, 4.
and 5, 1, 2, 3. Okay, that's it. That's all I think. Now, if I just repeat, we'll just get back to the first one. I need to change 1, 2, 3, and it will be 4 here. 1, 2, 3, 4. Right. So actually, this one we travel some distance each one, right? Yeah, that's right. Now here we have 5 times we change the tires. So that means that since we traveled 4,000 kilometers, so with each time we change this, we traveled 4,000 over 5, 800 kilometers. So that means that each tire, how many times? 4 times used. So that's 4 times 800. That's equal to 3,200 kilometers. Good. Nice question. And if you remember this question, they asked another question, maybe even they asked in S4, I don't know. They asked in grade 6, grade 7, grade 8, and this one is grade 9, and this one is yes, grade 8, right? So if the length of the square is 13, this time it is 13, and this one is equilateral triangle, right? Find the length of the triangle correct to the nearest whole number. Oh, this is a little bit different, I think. The diagram shows how an equilateral triangle can be cut into 4 pieces and rearranged to form a square. The solution of, okay. If the length of the square is 13, and find the length of the triangle correct to the whole number. Here, nothing is
39.
given, right? So we can find using this Pythagorean theorem then. Because if this one is height, this one is a over 2, this should be a, right? From here, what is h? H is equal to square root of a squared minus a squared over 4. That's equal to square root of 3 over 2a. So now from here, since areas are the same, area of the triangle is 1 over 2 times height, that is square root of 3 over 2 times a, and the base, that's equal to a. On the right-hand side, we have 13 squared, right? So what is a squared? It is 13 squared times 2 squared over square root of 3. So which means that a is equal to 13 times 2 over 4th root of 3. And that's why it says that 2 over 4 root of 3 is given 1.52. So which is equal to 13 times 1.52, which is equal to 1.52. What is it? 13 times 1.52. Okay. Hey, just small number, but with a calculator, we can calculate this. And now that's equal to 17.16. 17.16. That's the exact answer. Because in Sasmo, you are not allowed to use a calculator. That's why this thing is given. And you know how to multiply 13 by 1.52, right? Just 3-digit number and one 2-digit number. So 17.16. As I say here, S1, they ask a bit easier than S2. Actually, even they didn't give the height, so you need to find the height. And after that, 2 figures, they have the same area. And calculates. So last time, Arad, if you remember these polite numbers, we did similar question, right? At that time, the question was find all the polite numbers that can be expressed as the sum of 2 consecutive numbers. So later, actually, I tried that number, and every odd number except for 1, right? It can be expressed as the sum of 2 consecutive positive integers, like 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5, 5 plus 6. What are these? They're all odd integers, odd positive integers, except for 1. So the answer will be find all the polite numbers. These polite numbers are the positive odd integers except for 1 or greater than 1. But here it's saying that polite numbers are numbers that can be expressed as a sum of 2 or more consecutive positive integers. And find all the polite numbers that can be expressed as the sum of 3 consecutive positive integers. Find all the polite numbers that can be expressed as the sum of 3 consecutive positive integers. So I don't know how to find this. If you just make some observation, 1 plus 2 plus 3, that's equal to 6. Or 2 plus 3 plus 4, that's equal to 9. And 3 plus 4 plus 5, that's equal to 12. And 4 plus 5 plus 6, for example, it is 15. Right. What are these then? I can see here, these are all just multiples of 3, right? So that means that all multiples of 3, that is greater than 3, not itself, right? Not itself, that can be expressed as a sum of 3 consecutive positive integers. So that means that then all multiples of 3, not 3 itself. So they are, what is it? Polite numbers. They can be expressed as the sum of 3 consecutive positive integers. Is that correct? What do you think, Arat?
Yes.
I think so, because otherwise we have infinitely many. Of course, we cannot count this. And That's the way
Actually,
how we express this.
we can write it in another way as well.
How?
3 plus 3n.
3 times k plus 1, yes. And symbolically, that is a, what is it? Compact way. 3 times k plus 1, where k is natural number. That means that k starts with 1. So that means that it starts with, what is it? Um, 1. Okay, let's move to the next question. Find the 2015th term of the following sequence.
Impossible.
What? Why not possible?
Teacher, how can you find it?
No, 2015th term. We have 1 1, 2 2s, 3 3s, and 4 4s. Right?
But there is no pattern. The only way is we have to like do 1 plus 2 plus 3 plus 4. And it will
Okay, there's
take
a
like
pattern. Right?
I
There's a
mean patterns in terms of n.
So here we have how you solve this. Just again, in math, actually, if the question is difficult or complicated, just step by step, it's analogy, the simpler version. How can you do this? So now, if you just count this, here we have 1. How many? We have 1. Number 2, 2. Number 3, 3. Number 4, we have 4. And dot, dot, dots. Actually, here, what do you think? Do you think that we will have 2-digit number or 3-digit number, the last one?
3-digit number.
Okay, suppose that here we have 99. Okay, I have until, let me just write here 9, and starting from 10 to 99. Okay, and for example, let's say until 99. Okay, how many digits will we use here? Let's say, is it greater than 2015 or not?
Telescope method.
If it is greater than 2015, then also I will add some terms here. What did it say?
We will use telescope method.
Okay. Now here, for example, 99, right? Until 1 to 9, we know that we have.
Teacher, we can
Find
do
the
99 plus 1, 98 plus 2. So they will be 100. We have 49 of them, 4,900. Then we add 50. We get 4,950.
What?
It means then 99 would be 4,950th term. It means 2015 would be somewhere there.
Okay. Are you saying that if it is 99 is greater than 2015?
Yes.
Yes.
The
Okay,
teacher,
then
the way we
let's just show this. If, for example, 99, right? Let's say here we have 99, blah, blah. How many 99? See, here we have 99. Here we have 1 and 2 and 3 and 4, 99. So that is, the sum is 99 times 100 over 2. That's equal to 50 times 99, which is equal to, of course, the 50,000. So it doesn't work here. So it should be this 2015, okay? I can write it as 4,030 over 2, right? What is 4,030? Can I just write this 4,030 as a product of 2 consecutive integers that is close to 4,030, right? What is that number? Is 200, for example, 4,030, right? 4,030. So that is, how about 63 times 63? Okay. For example, 63 squared is equal to 3, 9, what is it? 6, 9. Okay, and how about 63 times 64? 63 times 64, that's equal to 4032. 4032. Okay, got it. So now, what does it mean? It means that if you just write this term, let's say 1 and 2 and 2 and 3 and 3 and 3 dot dot dot, and what is it? 63. And here we have 63 and 63 dot dot, here we have 63. Suppose that we just stop here. How many digits do we have here, right? To count this one, that is 63 times 64 over 2, that is equal to uh, what is it? 63 times 32, that's equal to 63 times 32, that's equal to 2016. 2016. Can you see that?
It means the answer is 63.
Yeah, the answer is 63. Because 2016's term, it is 63. 2015 is also 63. Actually, here we have 63 terms. Well, what is the idea here? We know that since 1 is used once, 2 is used twice, 3 is used thrice, and the blah, 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 right? And since we have 2015, and how do you find the sum of the first n natural numbers? The formula is, it is just equals n times n plus 1 over 2, right? So if this one is equal to some number near 2015, what is that? As you see here, it is 2016, because 63 times 64 is equal to 4032. And if you divide by 2, that's equal to, what is it, 2016. So that means that when we use until 63, at the time, how many terms do we have here? Will we have here? We will have 2016. So again, using just, we are using this idea, but can you see that or not? That's the tricky part. Okay, and after that, you get the answer here. Narmin, Javid, Hussein, are you there? Is everything okay?
Yes.
Okay, good. All right, any questions?
No.
Did we solve this question?
I was near to solve.
The diagram shows, Hussein, can you read the question? Let's listen to your voice. The diagram shows a rectangle being divided into 3 smaller rectangles and a square. If the perimeter of the unshaded rectangle is
did this.
54 and the area of the square is 64, find the total area of the shaded rectangles.
Teacher, we did this question.
We did, but the numbers were different, right?
No.
Only
Because I
the
remember
numbers were
it's
different.
64.
So this 8, this one is 8, and the unshaded rectangle. So if this one is A, let's say it is B, that means that it is 2 times A plus B, it should be 54. So A plus B is equal to 27. So this also B, and also this is A, this is 8. So this one is 8A, and this one is 8B, right? So 8 times 8 A plus 8 times A plus B, that's equal to 160, 202 square centimeters. Good. That's also, you are familiar with this, right? The idea,
Answer is
just
2.
x and with here 2 plus x equals x. So from here, x squared minus x minus 2 is equal to 0. Is it x minus 2 and x plus 1 equals 0? What is x? Equals 2, because it cannot be a negative number. So that's 2. Is it 2? 2, right? Yes. Now here 6 by 6. If it is 6, how many? 36, right? And because that's a standard question, if it is 66, the sum of the rectangles will be 36 plus 25 plus 16 plus 9 plus 4 plus 1, which is equal to, this one is 10 and the 35,
5 plus
20,
32
55, and the
and
90.
91.
But this is not so easy question. And here we have one more
Can we
question.
do it?
A, B, C, D. First try, okay. I mean, even
I in the
did you do
before I
this?
did it a lot, but I couldn't do.
You couldn't do this?
Yes.
And this kind of cryptarithm, actually, Alpha-Matica or Alpha-Matica. Anyway, cryptarithm, the most important factor, I think, okay, adding numbers and also thinking fast. Because if you don't think fast, it takes a lot of time. And also, actually, you need to find it in a systematic way, right? And the systematic way means how many different letters do we have? I have A, B, C, D, E, F, G, and the E, F, G, H, right, until H.
8
So
if
now we need to write here, we have A and the B, C, D, E, F, G, H. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 different letters, right? We don't have any other letter. So now also we know that we need to know that the letter in the first place, it cannot be equal to 0. That's the rule in this kind of question. It cannot be 0 because ABCD means we are talking about 4-digit number. EFGB means we are talking about 4-digit number. And also EFCBH, that means that we are talking about 4-digit number, right? And here we should start from the easiest one. So here we have also, let me just write numbers with digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because these are one of these digits. And different letters stand for different digits. So now if you start from here, right? E, it is, what is it in the, because the biggest digit is 9. 9, if you add this, it cannot be greater than 2. And that's why the value of E must be 1, right? It cannot be 2. So now
what
1 is gone. We have already used.
teacher?
And yes,
But why is it 1?
Arat, what is the biggest 4-digit number? 9999, right? Yeah, another 4-digit number, 999. But here, when you add this, can it be greater than 20,000?
Ah, sorry.
So it will be 10,000 something, right? That's why here, because A is a digit, E is a digit. The biggest digit is 99. If you add them, it's 18. Maybe if you get one from here, it will be 19. It cannot be 20,000. And that's why E should be equal to 1. That means that also here, I need to write maybe like this: 1, 2, 3, 4, 1, 2, 3, 4, and draw a line. Here I have 1. Actually, okay. I didn't solve it the first time I see this. That's just how we need to solve this. Here we have 1. I have here 1. It is plus. So 1 is already used, right? Okay. Now 1 is gone, and D plus B, C plus G, B plus F. Now, I mean, everybody should find one letter, then we can do this.
I found one thing.
What is
A
it?
plus 1 is equal to F.
Okay.
Because B and F is when they have remainder, and the remainder cannot be more than 1. Yes. And it cannot be more than 1, so I mean, yes. Then 1 plus A is equal to F.
Okay, here. So, what did you find? What letter did you find?
I found the equation.
No, no. Here, A plus 1 is equal to F, right? And we know that E is equal to 1. And suppose that if E is equal to 1, right? And for example, A is equal to 9. 9 plus 1, it is 10, right? If it is 10, it should be 0, right? If this one
Teacher,
is, for example, let's say less than 9, let's say 8. 8 plus 1, it cannot be at 10 here, right? So
but
this
there is one thing.
A must be 9. What is it saying?
Maybe these have like when we add this one, maybe it be 14. This C will be 4
No,
and it
from
would
B plus F maximum, we can get 1, right?
no, B plus
For
F we
example,
can
let's
get
suppose that A is equal to 9. Okay. What happens here? We have 9, right? 9 plus 1, it is 10. Maybe it is 0, right? Or if I get 1 from here, it will be 1. Is that so? Because here I have two possibilities. Either it is 0 or 1.
no, either is it 9 or 8.
It cannot be 8. How can it be 8? If it is 8, 8 plus 1 is 9, right?
Teacher, one second. 8 plus 1 is 9, but maybe B plus F, the answer be more.
Okay. Okay. So we have only two possible answers then for A. So A is equal to 9 or 8. If it is 9, 9 plus 1, it is 10, it is 0. So
And F
it
is
takes
0.
time. It takes time. Okay. Ara, let's stop here. Okay.
I found a way. F is 0, so B would be C.
Okay. Guys, Narmin, Arad, Eldar, Javid, at home, it's also interesting. Okay, you have one famous one, for example, when you just do this. But here, there's no shorter way, unfortunately. Only you need to try some numbers and guess some numbers and try them. So also the send more money, that's also famous. Okay, more money. There's one famous. When you have time, you can just try this, okay, because now it's already 1 minute past because I have another group waiting for me. We have another question here, 15 to the power of 2015, okay. And also you just see the pattern. The only way is if you just look at a few numbers and you will see that, what is it? When it is even, 6 to 5. When it is odd, this number. When it is even, it is this number. When it is odd, this number. Okay. The only way, actually, we need to see this, and after that, you can answer this question. And over here, we have one question left. That row is about seeds. Okay. Let me think about this. Still, I didn't have any idea. Sometimes we need to give some time to our brain, and after that, we may have original idea. Thank you very much, Arat, Narmin, everybody. And the next time we will move to S3, okay, secondary 3. And if you have time also, we need to practice some question from S4. And stage by stage, actually, we will move to the upper levels. Thank you. Okay, have a good night. I have to finish this meeting. I will meet you on Friday, guys. Thank you. Have a good day.
Goodbye.
Goodbye.
Bye-bye. Thank you.
Goodbye.
Bye-bye, Javid.